Welcome back. We're learning CosmWasm smart contracts. This is all about coins. This little video will teach you how to work with native funds. More and more funds are native these days. On CosmWasm chains, you're probably working with native funds. You used to work with CW20 tokens, but now usually native funds are the way to go. And we'll talk about that in a minute. But first, the basics of the coin struct. Every asset in CosmWasm is a coin. It contains two pieces of information: an amount, which is usually a micro value. It represents 6 digits. So if you have an asset like this, neutron, and you are working with it in this context, then you'll see a little U in front of it, U neutron. If we had easy access to a Greek keyboard, you would see micro neutron, right? The Greek letter mu, and that's what it stands for. It is micro neutron. So it's 1/1,000,000th of a neutron. Now, 1 unit of microneutron is 1/1,000,000th of a neutron. And same for any other asset generally. Generally, it represents 6 decimal digits. Similar to how on Ethereum, there are usually 18 digits. On Bitcoin, there are 8 digits, and so on. Here, we have 6 decimal digits. That's represented as a uint128, which is a special wrapped U128. It's not the strict type U128, which is a Rust type, but it is wrapped and gives us some additional utility. We will use uint128s back and forth. They both represent unsigned 128-bit integers. Plenty of space to hold large amounts, even though there are 6 implied digits. Then there's a denom, and denom strings can be one of several types. There are native assets like this. Usually that's the network asset, in this case, microneutron and microosmosis. But sometimes it's something else, like on a noble UUSDC, there's not a noble asset, right? So usually it's the network name is the asset, sometimes not. You don't have a lot of these though, because most assets come through in another way. They either come in as a factory asset, which is a token factory module of Cosmos SDK, allows you to create tokens that are not the network token. And you'll see this string where it's factory, a long address, a long format, contract address, and the ticker at the end is very helpful compared to a lot of other formats. For example, this IBC format. IBC assets are another kind of inter-blockchain communication assets. And this is a token that was on some other chain and has come across IBC and has now resides on our chain. It has a home chain. This could be a USDC from Noble, it could be a USDC from Osmosis, it could be Neutron, but it's on Osmosis, right? We don't know what this is unless we look it up somehow, or if we work with it very frequently, then like USDC, for example, maybe we have it as a constant somewhere. This long identifier here, it's not unique to the chain you're on. If you're on a different chain with the same asset, you'll have some different kind of identifier. So this IBC, for example, I'm going to guess that it is Noble USDC on Neutron. And in that case, this is the IBC identifier for Noble USDC on Neutron. But other than that, other than the complexities of knowing what it actually is and parsing this, you can work with it as though it's just a native asset. You send it around and so on, and use the amount field as you would with any other asset. Learn is brought to you completely free because of our great sponsors. Neutron, enabling developers to build breakthrough applications and onboard users from anywhere. Osmosis, the premier decentralized crypto exchange. And Obi, the smart new standard for asset management. If you want to become a smart contract developer through this lesson and others like it, head to heretolearn.xyz for uninterrupted course videos, coding exercises, and feedback directly from experts in the industry. Now, there is another asset type beyond the ones we've discussed, native, factory, and IBC, and that is the CW20 type. And I have it struck through here because we're not really going to work with it, and most people don't work with it anymore. But you will still run into it with some legacy tokens, as it used to be the preferred way to create tokens. And it still is in some context. It still is when you need to do special things with tokens that you can't do with factory. So we will work with similar ideas when we work with like derivative assets and things like that. But as we work with normal tokens in this CosmWasm course, we'll be generally using factory. And the downside of CW20 is that it doesn't work like a native asset, not handled at the native layer, has its own contract that handles things. And so event handling and how to pass it around and using it in the funds of a transaction and transferring and sending it, all these things worked generally differently with CW20 as opposed to native assets. But when we're working with factory assets, they work basically the same as native assets for our purposes. So we're migrating all our general token uses over to factory, and that's what we'll be working with in this course, but you will still run into CW20, especially as I frequently recommend the CosmWasm Plus contracts as something to look at. There are CW20 contracts in there, and you'll run into them. It's something you should be aware of. They have their own special receive messages, transfer messages, burn messages, and so on that you'll encounter, especially in the context of legacy handling. Now, how do you create, let's say you want to specify an amount, right? You want to create an asset in a denom, you can use the coin struct and do like a uint128 from a u128 and a denom and so on. But it's easier just to use the coin helper function. And coin lets you pass in a value, which you don't have to worry about converting into a uint128. You can just put it in there, and a string for the denom, and it will give you a coin struct back. So now tip is of type coin here, and we can interact with it appropriately. We can use it as funds in an outgoing transfer, something like that. And so you could create a vector of coins like this, tip equals vec, and then these coin calls within, or you can use the coin class. This is recently supported with the from string method to take a string that has an amount and denom in, which is normally how amounts are passed in from command line and so on, and just convert it into a coin. So easy, convenient function to get into the coin type. And you can work with the numbers, work with the denoms, and then compile them somehow up here. Or if you just have a raw string input coming in, then you can call it like this. But even more useful, and something you may not know yet, even if you're a CosmWasm Pro, is the more useful coins type, thanks to Larry, was integrated into CosmWasm, I think in 2023. And this lets you manage multiple balances easily. The coins struct will have multiple balances, and its member methods, when you add balances, when you subtract balances, manage the balances so that you can't have, for example, two UOSMO balances. You can't have two microneutron balances. If you add microneutron, it adds to the existing microneutron balance if it already exists. This is something that we often implemented ourselves in contracts before coins was available. They're naturally sorted alphabetically by denom, and like I mentioned, you don't have duplicate denoms. They're removed if a balance is zeroed, or they're merged so that you don't have duplicates. And an example here is I can create a coins default, which is just going to be empty, and then use the .add. Add isn't in the sense of adding an item here, but adding an actual amount of coins. So I can add more Osmo after this and more neutron after this, and it will just add to the balance. Likewise, there's sub, where you can subtract from the balance, and there are various other helper methods as well, like denoms will spit out all the denoms. You can get the largest coin amount and the smallest coin amount, and so on. I can come in and create a default coin struct, which will be empty, and then add coins to it and just give it this kind of format where I pass in the amount and the denom. This isn't add in the sense of like adding an item or adding a row. It's actually adding a balance. So if Osmo doesn't exist, then it will create it. But if I come in and I repeat this line and do it twice, then my Osmo balance will be 1,000. 3 times it'll be 1,500, because it adds to the balance if the balance exists, which is really handy. And you see that it's also alphabetical. After that, I have my neutron first. If I iterate through the coins, which I could commonly do, the first one's going to be neutron because it's alphabetical. It's just a convenient feature. But coins, again, it's new. You'll usually see people handling like multiple denom and multiple amounts themselves in older contracts. Coins is a much easier and more standardized way to do it, and you're going to be using coins in whales only. You'll use some of the special functions of coins. Coins has a denom function, which lets you get the list of just the denoms. It has functions which let you subtract imbalances and get the most and the biggest and smallest, and so on. A bunch of functions available for the coin struct that you will explore in the whales only coin exercise. And go to heretolearn.xyz.coin if you're watching this anywhere else to see the CosmWasm learning book on coins and other things on your journey to becoming a smart contract engineer for CosmWasm smart contracts.